All right, guys, let's talk a little bit about Euler's number. First of all, I know this is a weird name. It's actually named after a Swiss mathematician named uh, Leonard Euler. Um, like most things in math, he didn't actually come up with this number. It was actually another Swiss mathematician, Bernoulli, who came up with this number. But what you need to know is this number comes up a lot in higher level math. It's one of those things where it's kind of like pi. It just shows up in these equations, and you're like, what? um, along with pi, this is one of the most important constants in math. So, the first thing you need to know about it is it has a value of approximately 2.71828. So, anytime you see E, you can basically replace it with this value. You shouldn't have to. There's a button in your calculator. Whenever you type a lowercase e, pretty much any calculator is going to know what you're talking about. Okay. Um, so this is Euler's number. Now, why do we care? What's so important about this weird number? Um, so let's take a step back to how Bernoulli first discovered this number. So if we look at this compound interest formula, this was very interesting to a lot of people because, a lot of people, would take out loans and there would be this compound interest. But, if it's annual, okay, n is 1. Okay, if it's semi-annual, that would be 2. If it's quarterly, this would be 4. If this is monthly, this would be 12. If it's daily, this would be 365. But imagine that it compounded every second or every millisecond or, go down and down and down where n just gets bigger, 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 bigger. So what he did is he said, I wonder what would happen if I set this close to infinity, okay? As this approaches infinity, what would happen? So what I've done here, I've sketched the graph of 1 plus 1 over x to the x. And what I wanted to look at is what happens as x gets really, 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 really big. And that's what Bernoulli did. He said, hey, okay, what happens as this gets really, really, really big? And what he noticed is there was an asymptote. Now, this asymptote wasn't like 3 or like 2.5, okay? It was this weird number right here. And there's a lot of ways that you can get this number, all of which, unfortunately, is like an infinite sequence. Like you can only get approximations. But this number winds up being super, super special in lots of mathematical problems. One other property you need to know about this number is look at these two graphs right here. So this is an exponential with base e, okay? E to the x. And this is the graph of 1 plus x. Now, a special property of this exponential that happens on no other exponential is that as you get close to 0, the slope of this red guy gets close to 1. So when x is really, really, really small, e to the x is approximately equal to 1 plus x. Great, Mr. McClung, who cares? Okay, well, let's look at this compound interest formula. Now, let's say I wanted to change this formula to where n approaches infinity. N is getting really, really big. We're just compounding constantly. We call this continuous compounding. Well, if we do that, and we take a look at this right here, we can rewrite this, because remember, this is going to get really, really, really small because n is getting really, really, really big. So we can rewrite this as e to the r over n. What happens if we do this? Well, so I can multiply this. This is an r, by the way. If I multiply by n and I divide by n, these cancel out. I get e to the rt. Well, what does that do for us? It gives us this formula right here. Okay, this is our continuous compounding formula. And it seems a little bit like magic, but I just showed you where it came from. It came from this property of this exponential, where this guy and this guy are almost the same when x is close to 0. So this is going to be our continuous compounding formula, where this is our rate and this is our time. So Euler's number is going to come back. Later on, we'll talk about natural logarithms, which are base e. But I just wanted to show you a little bit of where e came from and how we use it.